Hello, this is your professor again, and in this video we're going to talk about defining the process. This assumes you've done your charter, you've set up the project scope, and now we're ready to look at some ways to visualize a process. And I've also asked you to watch a few YouTube videos related to what we call process mapping or defining the process. So in the learning module, you'll see links to what are called SIPOC models, SIPOC. I'll discuss them, and value stream mapping used in Lean. I won't specifically talk about value stream mapping today, but later in the course, when we get into some of the Lean tools, we will. So I do ask you to watch the video. So at this point, I'm going to go ahead and go into slideshow. Okay. And we'll, again, as I've said in the past, I won't discuss every slide in this set of notes, but I'll hit certain things that I want to emphasize. Okay. Basically, what is a process? And again, we discussed this in the course opening. Basically, it's nothing more than you have inputs, you do something to those inputs, and you produce an output. Okay. And a process can be manufacturing, it can be transactional. And I said earlier, you can tell if it's manufacturing if you can drop the output on your foot. So if you can't, it's transactional. It's a non-manufacturing process. Okay. This is a simple example of making microwave popcorn. Well, or any kind of popcorn. Yeah, it is a process, and the output is hopefully popped corn. Okay, so I'm going to talk about SIPOC, or some people call them SIPOC models, what I call input-output process maps, and something I refer to as deployment flowcharts. They're also known as swim lane charts. I'll explain that to you when I get to them. Okay. And first of all, and we stressed defining the scope of a project, and along with that, you typically define the boundaries. This is actually part of the scope. You can't typically do everything. So what we typically do is say, this is the process or some section of a process that we're going to focus on. Okay. And in making process maps, again, they're visual. That's their purpose. The idea is to have just the right amount of detail. This is not necessarily any hard and fast rule. You want enough detail so that people can understand how the process flows, but you don't want to have so much detail that the big picture of the process is lost. People generally put too much detail. I like to say, could a person who had no part in creating the process map look at it and with a little bit of background follow the process map? If they can and can understand how the process works, you're probably at the right level of detail. Okay. Again, make sure everybody understands the process that's being studied. Make sure you have set your boundaries. And by the way, if it's a physical process, people should go and walk it, look at it, watch it being done. When we get into Lean, that is considered extremely important. As they often say, go to where the work is taking place. Don't assume you know how it works. Go find out how it actually works. Because quite often what people think is happening in theory is not what's going on. We sometimes call that the hidden factory syndrome. There's an official way to do it that's somehow documented. Then there's the way people have over the years found they have to do it to get it to work at all. We often say it's hidden because a lot of it is undocumented. Okay, so I mentioned a SIPOC model. Again, I ask you to watch the videos. They're quite good. It's a high-level process map, and I like it as a starting point. Okay, So basically, you look at suppliers, inputs, processing steps, outputs, customers, and by the way, believe it or not, sometimes a customer can also be a supplier. They may supply you with something, and then you do something to it, and then you send it back to the customer. And then CTQs, critical to quality, these are used a lot in continuous improvement. They're basically the things you measure, the outputs of a process that are things that the customer is important to customer satisfaction. Okay, so here's a basic SIPOC model. Okay, pretty straightforward. Again, it's a nice high-level type of map. And again, I ask you to watch the YouTube videos. They're not very long, and they're pretty good in showing you some of the details. So here is a example. This is a simple example of a SIPOC model for making chocolate chip cookies. So we have suppliers. Where do you get materials from? Inputs, okay? And then the process. So we mix the ingredients, extrude the cookies, bake them, and cool them. And the output is chocolate chip cookies. And then what are the CTQs? The things the customer finds to be important. So taste, texture, shape, and so forth. So these are things we would want to have some measure of as part of our process. In other words, we want some measure of taste, texture, shape, hardness, moisture, and so forth. Also, something that doesn't get talked about very often, but sometimes the customer is not actually the end user. Sometimes you supply a project, a product that you're studying in your project, and that product actually goes, for instance, to a distributor or to a customer who turns around and then resells it to end users. Simple example, if you're Boeing or Airbus, you produce big commercial airliners and you make them for, American Airlines, United, British Airways, Lufthansa, etc., etc. But they may be the customers, but they're not the end users. We are the people who fly. So in looking at CTQs, you should also keep in mind things that are important to the end user. Okay, and this actually happens quite often, and sometimes the producer thinks only of that first tier of customers and they overlook the end user, and the end user doesn't like it. They complain to your customer and it comes back to you. Also differentiate between internal and external customers. Basically, an external customer is somebody who writes you a check for the product you produced. An internal customer typically would not. They're part of your organization, and you're supplying them with goods that they use to produce something else. Okay. Now let's talk about input-output process maps. These are pretty straightforward, easy to construct with a little practice. And by the way, when I talk about these types of process maps, this is not some sort of highly algorithmic, engineered concept. People generally, to some extent, will improvise here and there in the process or combine types of process maps. The goal is the map is clear, understandable, and above all else, it's actually accurate. Okay. So basically, in putting together a process map, often we start with things like a whiteboard or storyboard and Postit notes, and we try to get all of the steps in order. And we originally can do it with Postit notes because often you're going to go through iterations where people are discussing the process and you discovered you might have missed something, you might have something out of order. So we simply can add or move Postit notes around or even potentially remove some. Okay. Here's a simple example. Okay. So we decide where the process starts, and here we're just going to toast a piece of bread. So we just go, by the way, a rectangle in a map typically means a major process step, and the arrow, it's obvious, denotes flow. So we have a starting and a stopping point. Notice this process stops after the bread is removed from the toaster. So we do not talk about any further treatment of the toast. So the team has decided this is what the project will focus on. Okay, so here's an example. We often, at each step, will mention what are key process inputs. So you can just look through it, and we can put those below each of the key steps. Sometimes, at least at some of the steps, there are important outputs that we might measure or not measure, but we like to say, here are some things at this step that we like to keep track of. In other words, these are things that are important in the end to the customer. In other words, they will be critical to the customer. Okay. Sometimes we add specifications if they exist. So here's an example of the making a piece of toast. By the way, notice that they highlighted some of the inputs that they think are important. So the age of the bread, settings, temperature settings, and removal time. Okay, all of that makes perfect sense. And then the final output, hopefully, is toasted, slightly browned bread, although that would be part of the CTQs, how we would measure the final quality of the toast. And this is just an example, an industrial example of an input-output process map. This happens to deal with heat treating steel. And what they're actually doing here is they're heating up the steel, subjecting it to a carbon-rich environment. The carbon then diffuses into the surface of the steel and actually makes it harder. So you end up with a very hard surface, but the interior of the steel still has good mechanical properties such as fracture toughness and so forth. Okay. Some things to think about if you're doing process mapping. Again, I find the biggest problem is people get lost in the weeds. In other words, I don't claim this is easy, but you want just enough detail. Don't get hopelessly involved in every single little tiny detail of a project. Also, if you find yourself really struggling, you may have the scope is just too big. I've seen that happen where it's actually not one process. They group together a set of processes and they start getting very confused. So keep the scope manageable. Okay. Then I want to talk about what are called top-down flowcharts and deployment flowcharts. And the deployment flowchart in particular, I like. Okay, so they're also, as I said, you actually can find references to this. They're called swim lane flowcharts. So I'm going to talk about the deployment or swim lane chart. They have some similarity to the input-output map, but have a little bit more structure to them. And by the way, in process mapping, I should have done this earlier. These are just standard symbols that are used. Again, a rectangle indicates a major process step. You've probably seen this before. A diamond is a decision point. A terminator, this is where it ends. A circle would connect if you, for instance, had to go from one chart or one page to another page. And if documentation is involved, we typically use this symbol for a sheet of paper. In the examples we're doing, that would not necessarily come into play. But sometimes, as part of the process, there is documentation that has to be completed. Okay. So notice the idea of the deployment flowchart. And what happens with a deployment flowchart? okay, is that you keep track of all the different areas, or some people call them jurisdictions, that are part of the process. So notice here, we start where this is something simple, a restaurant providing food service. So I'm going to draw these lines. And by the way, that's why these are called swim lane charts, like an Olympic swimming pool with swimming lanes. So this covers each jurisdiction as you move along the process. So the hostess has a role, the wait staff has a role, so they take the order. The order is then sent to the kitchen. If there's a problem, for instance, you've run into it, oh, I'm sorry, we're out of that, then it bounces back to the wait staff, and they continue until they can make the order. Okay, so that's basically a deployment flow chart. And here's an example. This is one from a large Six Sigma project some years ago. And this has to do with how a company goes about deciding upon new products and how to introduce them. And again, I could go through here and draw swim lanes. Okay. And that's why these are sometimes called swim lane charts. I won't do all of them, but you can see this was a very complicated process, and in point of fact, it was much too slow. So once the team had finally mapped out this process with a deployment flow chart, they set about figuring out how to simplify it and then eventually put together what they would call what they call in Lean, the future state map. Okay. So just some things to remember as you're doing process mapping. Again, this assumes that you have surveyed the process. You've typically looked through the process steps. You may have gone and had interviews with people working in each step of the process. So you'll find things like duplication, unnecessary tasks, things are not being done properly. It's not clear who has to do what. Quite often, people find things like the documentation is wrong, the process steps aren't being done correctly. Those are things you can all fix on the fly. So you don't have to wait till the end of the project. If right up front you find obvious problems, you take care of them. Okay. And at the end, this is just a summary of the different types of charts. Again, I didn't really talk about value stream mapping. I just asked you to watch the video. They're used a lot with Lean, and basically a value stream map is similar in how it works to a deployment flow chart, except its focus is really on time and flow. Okay, in the process maps, we often don't worry so much about things like cycle time through a process, which we do in Lean. And so the process map isn't as time oriented, but value stream maps and I think deployment flowcharts are particularly two powerful tools to visualize a process. And as I said, I think a really good starting point is a SIPOC model.